Oh, hello there. Did you know that when Francis Crick and James Watson evaluated the complex structure of DNA in 1953, it probably never occurred in their minds that contemporary scientists would one day use the tens of thousands of human genes that map out the billions of coded letters, more importantly, that their work would lead to bioprinting, the engineering of skins, stomachs, heart valves, and even hearts. So here, I'll show you. There is a lot of jargon that goes into the process of printing an organ. In fact, more than I have time to explain, and more than you care to listen. But the printing process is the same. Once the technology is developed, it'll be like clicking away at a computer, and now comes one of these. It's the desktop drugstore, but instead of only being able to treat the flu and pneumonia, we'll be curing Marfan syndrome, congenital heart defects, and diabetes. And the best part of it is, once the organ is transplanted, there isn't a risk of the body's immune system rejecting it. Bioprinting could dramatically cut the costs of transplants, serve the developing world, and remove the organ supply cap. The demand for organ donations is far beyond the number of donors, and the gap is only getting wider. In the United States alone, there are 120,000 people or more who need a vital organ transplant, and approximately 18 of those people die per day from a lack of organ availability. Organ transplants are in such demand that its current supply only covers 10% of the global need. And if you're lucky enough to be called for an organ, well, now comes the matter of affording it. You need a lung? How about two? Well, you're going to need a liver to live. And the cost of a heart? Bioprinting is serving the needs of the future. And then some.